We also want to look at how to combine functions. Right now up here on the board I have f of x equals 2x minus 1 and g of x equals x squared plus x minus 2. And the first thing I want to try and do is, what in the world is this thing? F plus g of x. Well, f plus g of x equals f of x plus g of x. And once I can find out where f of x and g of x are, I just add them together. So f of x is 2x minus 1 plus the entire g of x, which is x squared plus x minus 2. And I'm going to put parentheses around those just to help visualize exactly which is f of x and which is g of x. In this particular problem, the parentheses don't matter other than just to give me a visual separation. And now my job is to go ahead and combine like terms. There's an x squared. X's, a 2x plus an x gives me a 3x, and a minus 1 and a minus 2 gives me a minus 3. So f plus g of x equals x squared plus 3x minus 3. Now let's look at f minus g of x. And here you might see why the parentheses are important. So f minus g of x, well, what do you think that's going to look like? That's going to look like f of x minus g of x. F of x, again, is designated up here as 2x minus 1, I'll put parentheses around it, minus g of x, which is x squared plus x minus 2. Now be careful here. Notice that if I don't put parentheses around g of x, my subtraction falls apart. Because in this case, the subtraction is telling me only subtract that first term, when in fact I need to subtract the entire function. So I'm going to put parentheses around it so that subtraction distributes all the way through. 2x minus 1 minus x squared using distribution property minus x. Minus times a minus 2 gives me a positive 2. And now I can go ahead and combine like terms. I have a negative x squared. 2x minus an x gives me a positive x. Negative 1 plus a 2 gives me a positive 1. And so therefore I have the solution to f minus g of x. Continuing on, we have fg of x. And that means f of x times g of x. And so now I get to practice and dust off my skills in multiplying polynomials. So f of x is 2x minus 1. Multiplying it by g of x, which is x squared plus x minus 2. And depending on how you like to multiply them, if you like to stack them on top or multiply across, just for now, let's multiply across. So 2x times x squared, 2x squared, 2x times a positive x gives me, 2x cubed. Thanks guys for catching that. 2x times x gives me a 2x squared. 2x times a negative 2 gives me a minus 4x. Negative 1 times x squared gives me a negative x squared. Negative 1 times an x gives me a negative x. And negative 1 times a negative 2 gives me a positive 2. Again, what I did here is I distributed the first term all the way across to each term. And then I distributed the second term all the way through. And actually I had 6 applications I needed to do right there. Now it's my job to go ahead and combine like terms. And I have cubes, so I have a 2x cubed. I have x squareds, I have 2x squareds, take away an x squared, leaves me just 1x squared. Minus 4x minus x gives me a 5x. And then a positive 2, I'm left with a positive 2. And lastly, let's go ahead and divide functions. So the last one I have is f divided by g of x. And as you would expect, that's the function f divided by the g function. And so that would equal f of x is 2x minus 1 divided by g of x. And then I want to check to see if it reduces in any type of a way. Sorry, 2x minus 1. There's no factor in here. that takes that factor out, so that is in simplified form. So that's my final solution of f divided by g of x.